Welcome back. In this lecture, we will discuss on how do we customize node configuration for AKS node pools. So there may be a need of special values of kernel parameter or kubelet parameter in order to run the workload on the AKS cluster. You can customize node configuration and kubelet configuration during the creation of AKS cluster or addition of node pools. Now let's understand it practically. Here I am in Azure. Just before start recording this lecture, I already launched a default single node AKS cluster off screen. Let me walk you through that from the Azure portal. I have a Kubernetes service here. Let's click on here. I have my AKS cluster available. Let's click on the cluster. I have my cluster running within the resource group, my resource group. Let's click on the node pools. I have one node pool available, that is default node pool, and this is system node pool. The node pool name is node pool 1. Now let's fire up the Cloud Shell and run kubectl get nodes -o white command. I can see one node is running. Now let's go ahead and log in into the worker node. The command to log in into the worker node is kubectl debug node/node name -it-image is equal to mcr.microsoft.com/.net/runtime-deps:6.0. That's the image which we are using. Hit enter. Now you need to run chroot/host command. So now I'm logged in into the worker node. Now let's check few operating system and kubelet default parameter values, and then I will launch a new node pool with the updated parameter values, and then we will log in into the worker node. Part of new node pool will see the updated values of those parameters there. Let's first run command cat/proc/sys/vm/max_map_count. This value defines maximum number of memory map area a process may have. Hit enter. The default value to this parameter is 65530. I will update this value to some other value in the new worker node as part of new node pool. Let's check another parameter. The parameter name is vfs_cache_pressure that controls the tendency of kernel to reclaim the memory which is used for caching. Hit enter. So there is a default value set to this parameter, and that is 100. Let's check another parameter. The parameter name is memory.swappiness. This parameter shows how aggressive the kernel will swap memory pages. Let's hit enter. So currently it is 60. Let's see the next one. Transparent hue space. It is a Linux kernel feature intended to improve performance by making more efficient use of processors' memory mapping hardware. So by default, the value to this parameter is set to always, and we are going to change that to never. Now let's check the swap size. The command for that is swap on-s. By default, there is no swap file, but we will plan to create 500 megabit of swap file. Now let's check sysctl socket and network parameters. The parameter name is somaxcon. This defines net core socket max connection. Let's hit enter and see the default value. It is currently set to 16384. I will change it to something else. Let's check another parameter. The parameter name is IP_local_port_range. This parameter defines the local port range that is used by TCP and UDP traffic to choose the local port. So by default value to this parameter is 32768 and the last value is 60999. We will change this value as well. Okay. Now let's go ahead and exit out of this worker node. In order to change Linux operating system node configuration, I will create a Linux OS config.json file and will mention all the updated values to those parameters there within that file. I had already created a file. The file name is Linux OS config.json. Here are the new values to those parameters which we just discussed. Transparent hue space enabled is set to never. Swap file size MB to 500. sysctl's parameter vmmax map count is set to 65550. VM VFS cache pressure is set to 50. VM swappiness is set to 70. Net core somax connection value is set to 4200. Net IPv4 local port range is set to 32,000 to 60,000. Similarly, you can change kubelet configuration also. In this demo, I'm going to change three parameters. CPU manager policy is nothing. It is static policy which allows containers in guaranteed port with integer CPU request access to exclusive CPU on the node. CPU CFS quota, which enables or disables CPU CFS quota enforcement for the container that specify CPU limits. Container log max files, the maximum number of container log files that can be present for the container. Let's create another file called kubelet.config.json. In fact, I already have that file available, kubelet.config.json. These are the new values to those parameters. CPU manager policy, CPU CFS quota, CPU CFS quota period, container log max files, and fail swap on. In addition to that, you can change other operating system settings also. Let us say you want to change default message of the day to each agent node. That is also something which is possible. Let's create a file called new motd.txt. In fact, I already have that file available. So the file is new motd.txt. The content of the file is hello. This message is a custom message. Right. So we have three files available: Linux OS config.json, kubelet config.json, and new motd.txt. Now we are going to create a new node pool with one worker node with these updated parameter values. Here you need to pass in Linux operating system configuration, kubelet configuration, and message of the day file. Hit enter. Node pool addition will take some time, so let's come back once the node pool is available. Node pool is now ready. Let's run kubectl get nodes command. I can see two worker nodes now. This one is part of node pool 1, which is system node pool, and this one is part of node pool 2, which is user node pool. Let's open a new session. Let's run kubectl nodes-o write command once again onto this new session. And here, this is the node name. Let's log in into the new worker node using kubectl debug node name. That is going to be this one. Let me copy it and paste it here. I'm logged in. This is worker node 2. Now let's run chroot/host command. Now I will see all the parameter values onto this worker node and will compare it with the parameter values onto worker node, which is part of node pool 1. So let's go to the old session. So these are the commands which I had run. I will just copy this command and we'll paste it and we'll run it onto this worker node. The value is 65550, but on the old worker node, the value was 65530. Now let's copy this command, run it onto the new worker node, hit enter. The value is set to 50, but it was 100 onto the old worker node. I'll just copy the next command. We'll run this command onto this worker node. The value is 70, but earlier it was 60. Now I'll just copy the next command. We'll run it over here. Transparent underscore hue space is set to never, but on my old worker node, it is set to always. Now I will run swap on -s. I can see a swap file of size around 500 MB. So that is available onto this worker node, part of node pool 2. But on the worker node part of node pool 1, the value is nothing. So there is no swap available. I'll just copy the next command. We'll run this command onto this worker node. I can see the value is 4200, but on node pool 1 worker node, the value is 16384. Let me copy the next command. I'll just run it here. The value is 32,000 to 60,000. On worker node 1, part of node pool 1, the value is 32,768 to 60,999. Right, so now we have a new worker node available with updated operating system parameter values. Right, so similarly, we can check for kubelet. I should see a kubelet.json file available onto this worker node. I'll just run cat default kubelet. Let me run bash command and then run cat etc default kubelet config.json. Hit enter. Now you can see all the values are updated. You can directly run this command. It will show you all the values. CPU manager policy is set to static. CPU CFS quota is set to true. CPU CFS quota period is set to 200 ms. Custom CPU CFS quota period is set to true. and container log max files is set to 3. That is something which we had set into the file. Now we can see MOTD message file also. Let's run cat etc MOTD. Hit enter. You can see that custom message available onto this file, right? So this way we can customize node configuration operating system parameters and kubelet parameters during the creation of AKS cluster or addition of new node pools. That's it for this lecture. Thank you.